Welcome back, guys. In this video, we got to solve for m, the constant m, in each of these three scenarios. So the first scenario is negative 5x squared minus 4x plus m has 1x intercept. So let's rewrite that over here. We got y equals negative 5x squared minus 4x plus m. So what value of m would make this quadratic have one x-intercept? So we know when there is only one x-intercept, the discriminant is equal to 0. And we know the discriminant is b squared minus 4ac. So that's going to equal 0 when there is one x-intercept. So notice that with this quadratic here, the a value is negative 5. The b value is negative 4, and then the c value is m, right? It's that constant right there. So what we can do is we could plug all of these here into this equation and then just solve for m, isolate for m. So we'd have negative 4 squared minus 4 times negative 5 times m, the c value is m. That's going to equal 0. So this would be 16. Negative 4 times negative 5 times m gives us positive 20m. That's going to equal 0. So to isolate for this m here, bring the 16 over. So 20m equals negative 16. So m is what? Negative 16 over 20. And that simplifies to negative 4 over 5. So at that m value, negative 4 over 5, this quadratic will have one x-intercept. And that's because the discriminant is equal to 0. Moving on to number 2, we're told that f of x equals mx squared minus 8x plus 4m has no x-intercept. So I took this quadratic, rewrote it up there. So if a quadratic has no x-intercepts, then we know the discriminant is less than 0. It's going to be negative. And the discriminant, as we know, it's b squared minus 4ac. So that's going to be less than 0. So this quadratic here, what is the a value? What's the b value? What's the c value? Well, the a value is the constant that's in front of the x squared. So notice that is m. The b value is negative 8. C value is this entire constant right there, so 4m. So what we can do is we could take all of those and plug them in here. So b is negative 8, so it'd be negative 8 squared minus 4 times m times 4m, and we have to solve when is that less than 0. So this would be 64, and this would be negative 4 times m times 4m, so negative 16m squared. And this has to be less than 0. Now, there's multiple ways to solve this. Once you get to this point, once there's a quadratic here, I would factor it or find the intercepts. So let's rewrite this, negative 16m squared plus 64. When is that going to be less than 0? Well, we could factor out a negative 16 from both of these, so we'd have m squared, 64 divided by negative 16 is minus 4. And then this, m squared minus 4, that's the difference of squares, that factors into m plus 2, m minus 2. We're solving when is that less than 0. And what I do at this point is I actually graph this. So we know this quadratic here is factored. So we know the x-intercepts are what? Negative 2 and positive 2. So this is negative 2. This is positive 2. And we know this quadratic is going to be opening down because of that leading coefficient being negative. So it's going to look something like this. You don't have to draw it exactly to scale. You don't have to get any other points. All you have to know is the two intercepts and whether it opens up or down. And now you could tell when is this going to be less than 0. Well, it's going to be less than 0 here and over here. So basically when m is less than -2 and when m is greater than 2. In both of those cases, the discriminant is going to be less than 0. Now, this quadratic is different than the one we're working with, right? We're just solving this inequality here. So the way I'm solving it is visually. So I'm taking this quadratic here. I'm forgetting about everything else. I have this quadratic. When is this quadratic -16m squared plus 64 less than 0? When is it below the x-axis? So what I do is I graph it. So I know it's going to be opening down. I get the intercepts, plot them, and then visually I could see this quadratic is going to be less than 0 when m is less than -2 and when m is greater than 2. So those are the two solutions. And then finally, moving on to the third scenario, we got f of x equals 4x squared plus mx plus m plus 5, and we're told that it has two intercepts. So what values of m will this quadratic have two intercepts? Now, if there's two intercepts, we know the discriminant is going to be greater than 0. It's going to be positive, meaning b squared minus 4ac is going to be greater than 0. So, looking at this quadratic here, what's the a value? What's the b value? What is the c value? So the a value is a constant that's in front of x squared, so 4. The b value is a constant that's in front of x, which is m in this case. And then the c value in this case is both of these here. M plus 5 is a constant. There's no variables in front of either or. So that whole thing is the c value. So it's m plus 5. Okay. So now we could take all of those, plug them in here. So we'd have m squared minus 4 times a, which is 4, times c, which is m plus 5. And we have to find when is that greater than 0. So like I did in the second scenario, I'm just going to expand this quadratic here, and then I'm going to graph it. So this would be m squared. Right here, this would be minus 16. Negative 4 times 4 is negative 16, and then we could distribute inside the bracket. So negative 16 times m gives us negative 16m. Negative 16 times 5, that gives us negative 80. And we have to find when is that greater than 0. So I would factor this here. And this actually factors smoothly. We got m minus 20, m plus 4. We have to find when is that going to be greater than 0. So now we could graph this quadratic. Notice that the intercepts are what? Negative 4 and positive 20. Not to scale, but again, all we need is the two intercepts, whether it opens up or down. This is opening up. Notice there's a positive 1 in front of that m squared. So this would be a quadratic that is opening up. Right? So when is this quadratic going to be greater than 0? When is it above the x-axis? Well, over here and over here. So basically when m is less than negative 4 and when m is greater than 20. Those are the answers. That's when this quadratic would have two x intercepts, either or of those scenarios. What if they asked you if this quadratic has no x-intercepts? Then we would be solving when is this less than 0. And when is it less than 0? It's less than 0 in this area here. So when m is between negative 4 and positive 20. So that there would be your answer if the question was asking you for this quadratic to have no x-intercepts, because the discriminant would have to be less than 0. So you'd be solving less than 0 here. and it's less than 0 between -4 and 20 in this negative region. What if they asked you for this quadratic to have one x-intercept? Well, that would be when the discriminant is equal to 0, and this quadratic here is equal to 0 at -4 and 20. So when m equals -4 or m is equal to 20, that would be the answer for one x-intercept, right? So this is the answer for two x-intercepts, no x-intercepts, one x-intercept. But they just asked us for two, so that's the answer, but thought I would point that out in case they ask for all three in a question. So when you get something more complex like this, factor it out, graph it. All you need, again, is the factors. You need the two x-intercepts, and then whether it opens up or down. Then you just draw it, and then you can visually see when is it equal to 0, when is it greater than 0, when is it less than 0. Whatever you're looking for, you can easily get from the graph. So that's how you do it. Another tricky part is just knowing what's the A value, what's the B value, what's the C value. We're going to do more complex questions in future videos where getting the A, B, and C is a little bit more tricky.